we're going to be looking into this new chapter. Okay, so this new chapter is about electronics. So we started with electricity, okay, and then we went on to electromagnetism, where we looked at how electromagnetism is used in both small scale and also in big scale. Okay, and this is the third part. Actually, not even the third part lah. This is a whole new branch of physics altogether. Okay, so in electricity, in chapter 3 and chapter 4, it comes under this branch called electricity and electromagnetism. Okay, that's this branch of physics now. Actually, even physics itself, electricity is one branch, electromagnetism is one branch. But because they're so connected to one another and they involve things like, current, resistance, all those things, so they are kind of longer together. But when we move to this side of, to this part of physics, okay, we're talking about even smaller things. Okay, we're going even smaller than just the basic transformer or the basic magnet or the basic solenoid. Okay, and so this is a branch of physics which is also known as electronics. Okay, and when we talk about the word electronics, the first thing we have to consider is the word electron. Okay, because the okay, electronics comes from the word electrons. So we're talking about how electrons help us, okay, how the concept of electrons help us in our technology today. Okay, so it's all to do with technologies that involve the movement of electrons, involve the working of electrons, okay, at a very molecular level. So we're going even deeper into the smaller things. Okay, so which is the pretty amazing thing about your Form 5 syllabus. So, you started with all this, benda di dunia nyata, which is forces and motion. And then you talk about pressure. Okay, and then after that, you go into electric. So it's all these things that we can see in real life. Okay, we can see it. Okay, but then when we go to chapter 5 and then later in chapter 7, we're going to all these very, very tiny things. Okay, which still make up a part of our physical world. Okay, and it's still a part of physics. Okay, but it's on a totally different scale altogether. Okay, it's on a very, very tiny scale. Okay, so we're going, but then suddenly chapter 6, it becomes very big again. So I also don't know why. Okay, but one of the main uses of electronic technology, okay, and this is very old school. If you've ever seen this kind of TV, yang belakang tu sangat besar itu, I don't know if you guys still have this TV at home, or even computer monitors. Okay, not the kind of computer monitor that Mantani has in his house, but the old computer monitors on the big butt at the back, right? So you kind of wonder, what is in that butt? What is in that behind part? Why is it so big at the back? And then why is it now that today we don't need that big behind anymore? Okay, even this machine which we see over here, okay, there's this huge big back part to this. Okay, and we kind of wonder what is in here. What is in here that causes your your screen to be able to show the tit itu? What is it in here that causes this picture to be seen? Okay, or what is it in here at the back over here that causes this, your monitor to light up? Okay, so again, now what information can we get on the graph? Is all this. How is the picture formed on the screen? So the heartbeats of a patient in a hospital can be monitored by using this device, which is called a cathode ray oscilloscope. Okay, so this is probably the most basic thing about electronics. Every electronics student, okay, has to know about how the cathode ray oscilloscope functions. Because when you understand how cathode ray oscilloscope functions, okay, then you will understand the rest of you will begin to understand the rest of electronics. Okay, now I realize that whenever I teach this, okay, some physics students I mean, after a while, you will know, even in physics, you will know where your interests lie. Some people like the big stuff, okay, like electromagnetism is big okay, you can see it, and you can explain it. And some people like the really small stuff, like electronics. Okay, so I hope that in studying physics, you don't just look at physics as a subject, okay, but you look at it as different branches, and it's an introduction to the different branches there are in physics. Some people, for some strange reason, okay, they like heat. Okay, Generally, I think your form, heat is the worst chapter. Everybody doesn't like heat. I don't know why. But there are some people that really like heat, it makes sense to them. Okay, so, different branches of physics. Your entire Form 4 and Form 5 is just like that. Like I said, introduction to the different branches of physics. So that mana tahu when you leave school, or if you go to, you kind of know where your strengths in physics lie. Okay, maybe you're the kind of person that likes electronic engineering, which is, all this small stuff. Maybe you're the kind of person that likes to deal with heat for some strange reason. Okay, heat lah or something lah. So, so yes, anyway, the cathode ray oscilloscope is probably the most basic thing about electronics that everybody has to know. Okay, how is it that this gambar boleh terpapar di screen? Okay, I bet that none of you have ever thought of this before. You just accepted the fact that, oh, the picture appears on the screen, but you never asked, how is it that this picture can appear on the screen? What is the explanation for the reason why these things can appear on the screen? When you watch TV, even as you're watching this Google Meet now, have you ever wondered how the picture is appearing on your laptop? How is the picture appearing in your phone? How is the picture, when you watch Netflix on TV, how does the picture appear? Does it just like that? Okay, so the explanation behind this, okay, the basis of the explanation, I'm not saying that this is how, but the basis of the explanation, okay, is explained by the cathode ray oscilloscope. Okay, it works by emitting electrons, okay, from the process called thermionic emission. Okay, I want you to underline or highlight this word because this will be a very important word in our study today. Okay, so the first thing we need to know is how to explain thermionic emission and what are cathode rays. Okay, so the surface of a metal contains a large amount of electrons. So any metal, okay, any metal, the surface here has a lot of electrons. Okay, and so the question is we have to ask is what are free electrons? So metal consists of a large number of electrons, okay, which are free to move. Any metal, okay, there are a large number of electrons which are free to move, and at room temperature, the electrons are free to move, but they remain inside the metal. They cannot escape. Okay, they're just there and they're like la 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 la. There's no reason for them to move because they're very comfortable. It's room temperature and they love it there so much. So it's just like, okay, we just remain there. Sebab kalau kamu tiada sebab untuk berpindah, bahkan kenapa kamu mau berpindah? There's no reason. So the electrons cannot escape, okay, at the surface because they are held back by the attractive force of the atomic nucleus. So actually, in actual fact, it is not that they don't want to run away. They may want to run away, but they cannot because number one, it's at room temperature, and number two, at room temperature, all the nucleus of every atom is actually pulling, okay, it's actually pulling the electrons towards them. So the best thing that they can do is they just orbit around the nucleus lah. Okay, they can't really escape because they are being pulled. Okay, mereka macam terikat kepada, they're like terikat kepada atom. So my question to you is this, and we have actually studied this before lah. What will happen to the energy of the electron if the metal is heated? What do you think? What will happen to the electron's energy when we heat it up?
It increases.
Okay, the energy will increase. Definitely, when you provide energy, when you provide heat, okay, to any substance, the energy of that will increase because you're giving it more energy. Okay, so the energy of the electron increases. Now, what happens to the free electrons, okay, if the metal is heated at a high temperature? What is going to happen is that the electrons will gain sufficient energy to escape from the metal. Okay, let me remind you, at this moment, okay, at this moment, yes, they are free, but they are not entirely free. They're just free to move around, as long as they don't escape the pull of the atomic nucleus. So in order for them to escape, we have to give them some form of incentive to escape. And the incentive comes in the form of heat energy. So we provide heat energy to the electrons, okay, and the electrons will gain kinetic energy. They will move faster lah. They will move faster until they gain sufficient energy, tenaga yang mencukupi untuk terlepas. They will be free from the nucleus. the pool of the nucleus. Okay, it sounds like a very dramatic kind of movie story, right? Okay. Oh, this, yeah, saya dibelenggu, no, I'm captured. So how do I come free? So somebody has to come and rescue me. Wow. Okay, so it's like, you provide the heat. You provide the heat, electrons get enough heat and they will get enough energy to escape. So the name of this process is called thermionic emission. Why thermionic? Because the word therma lah. Okay, therma refers to the word heat. Okay, macam thermal equilibrium. Okay, so thermionic. Now ionic because there are ions involved here and specifically electrons lah. Emission, okay, emission is pelepasan lah. Okay, you emit lah. Okay, you emit this one. So the thermionic emission is the emission of electrons. Okay. What is it in Malay? Emission is not pelepasan. The release lah, okay? The release of electrons from the surface of a heated metal. Okay, when you heat up a metal, the electrons over there are going to be released. Okay, the free electrons yang tidak terlalu terikat probably valence electrons lah. Okay, if you remember your chemistry, valence electrons are the most paling luar bahkan. So the most outside electrons are the ones that are furthest from the atom, from the nucleus of the atom. Okay, so it is those electrons that are being, freed lah. Okay, that are being emitted. Okay, of course the question is, lepas kita bebaskan ini elektron, mau pergi mana? Kan? It's like, why do we want to release these electrons? Why can't we just, biarlah diorang di sana, kan diorang comfortable sudah. Okay, so there is a reason why we need these electrons to be free. Okay, so this is a pretty amazing scientific discovery. The person who discovered this is that, wow, if we can actually release these electrons, they can serve a purpose for us. Okay, which is, why we are able to watch television today. So you should be grateful. You should be grateful for whoever discovered this thermionic emission, because without that discovery, we would not even be, doing any Google Meet. You would not even be watching any Netflix or, or whatever lah. Okay, or going on Twitch or playing whatever games. Without the discovery of thermionic emission, we will always be looking at the blue sky and the green trees. Okay, wondering what form of entertainment there is for us. Thermionic emission is literally, okay, a scientific discovery that changed the world. Okay, because it brought about the technology of the TV, which brought about the technology of a lot of other things. Okay, so thermionic emission is the emission of electrons from the surface of a heated metal. Okay, let's watch this video. Can you hear?
Salam sejahtera semua. Saya Nadia. Hari ini kita akan belajar tentang oscilloscope sinar katod. Kita bermula dengan mengenali proses pancaran termion. Permukaan sesuatu logam mempunyai banyak elektron-elektron yang bebas. Pada suhu bilik, elektron-elektron ini terikat pada logam kerana tidak mempunyai tenaga kinetik yang mencukupi untuk membebaskan diri. Apabila logam itu dipanaskan pada suhu yang tinggi, elektron-elektron ini mendapat tenaga kinetik yang mencukupi dan mampu membebaskan diri dari permukaan logam. Proses ini dikenali sebagai pancaran termion. Faktor-faktor yang mempengaruhi pancaran termion adalah A. Suhu logam, B. Luas permukaan logam, dan C. Jenis logam. Logam yang amat sesuai adalah tungsten, barium oksida, dan strontium oksida.
Okay, sorry, there's a second part to this now. Hold on. But doesn't the girl look like Eva?
Ialah suatu tiub kaca yang divakumkan dengan satu elektron positif, iaitu anod, dan satu elektron negatif, iaitu katod. Filamen yang bertindak sebagai katod hanya akan dipanaskan dengan beza keupayaan 6 volt bagi menghasilkan pancaran termion. Pancaran ini menumpu sebagai suatu alur elektron yang halus selepas melalui lubang halus dalam silinder anod. Alur elektron ini dikenali sebagai sinar katod. Apabila sinar katod menghentam skrin pendar fluor, tumpuk cahaya terhasil disebabkan tenaga kinetik elektron bertukar kepada tenaga cahaya. Osiloskop sinar katod digunakan dalam bidang sains, perubatan, kejuruteraan, telekomunikasi dan industri. Mari kita lihat struktur dan prinsip kerja osiloskop sinar katod ini. Osiloskop sinar katod (OSK) ialah alat pengukur dan penguji gelombang yang terhasil oleh pelbagai isyarat elektronik. Tiga bahagian utama yang terdapat pada OSK adalah senapang elektron, sistem pemesongan, skrin pendar fluor, senapang elektron, filamen pemanas, memanaskan katod, katod, memancarkan elektron, grid kawalan, mengawal bilangan elektron, anod memfokus, menumpukan alur elektron pada skrin, anod memecut, memecut alur elektron, sistem pemesongan. Plat Y berfungsi mengawal pesongan alur elektron secara menegak, iaitu ke atas atau ke bawah. Plat X berfungsi mengawal pesongan alur elektron secara mengufuk, iaitu ke kiri atau ke kanan. Skrin pendar fluor. Tenaga kinetik elektron setengah MV kuasa 2 ditukar kepada keupayaan elektrik EV apabila ia memecut di antara katod dan anod. Seterusnya bertukar kepada tenaga cahaya dan haba apabila alur elektron menghentam skrin. Oleh itu, halaju maksimum elektron dapat dikira. Sekarang, kita lihat bagaimana osiloskop sinar.
Okay, thank you, Eva. So, I really think it looks like her. Don't you think so? Okay, so the Eva look like the Eva, apa ini? The doppelganger. Okay, so she's introducing a lot of new things lah. Okay, that some of it is actually in the old syllabus and some of it is not. Most of it is not. Okay, but the most, let's change picture lah. Okay, this looks very scary. Okay, so a few things that you're going to hear a lot, okay, in this one. If I will send you the video now if you want it. So a few things you're going to hear is that the process of thermionic emission doesn't end there. Remember the question I asked just now. So what if you want to release these electrons? Where are these electrons going to go? Tiada guna kalau kamu bebas dari penjara. Lepas tu bila kamu keluar dari penjara, bahkan kau tiada matlamat hidup. Bagus lagi kau duduk di penjara. Kan? If you have no goal in life, after you get released from prison, it's better to stay in prison because at least there kan ada rutin harian. Wow. This is very bad teaching. Okay, but the same thing. For electrons, once you release the electrons, then you have to ask the question, for what we want to release the electrons? Kenapa kita mau bebaskan ini elektron? Untuk apa? Okay, and this is what is happening lah. So when a coil is heated, okay, the electrons are emitted. Okay, and the electrons are emitted, and this process is called thermionic emission. Okay, so what will happen if the electrons that are emitted in an anode, okay, let's call this an anode lah, okay, is placed in a vacuum tube. Okay, if an anode is placed in the vacuum tube, because we know that all this, since these are electrons that are being emitted, so we're going to call the place where the thermionic emission happens, we are going to call this the cathode. Okay, the cathode or the negative plate lah. Okay, and so what if we put the anode, what if we put a positive plate over here? What do you think is going to happen to these electrons?
It will move towards the anode.
It will move towards the anode. Okay, because this is very basic physics. The negative will always be attracted to the positive. Okay, it will flow towards the anode. If you give it a place to go, kalau kamu beri dia satu tujuan hidup, okay, it will go there. Wow. Okay, if you give it a place to go, it will go there. And because we put an anode over there, the anode is going to say, come here, come here, come here. So the electrons are going to go. The electrons will be accelerated to the anode. It's very, very, very the laws of physics in this world. Okay, if you don't give a place for the electrons to go, the electrons will just float around and do nothing, and be totally useless, menjadi penganggur. But when you give it a direction, when you give it a goal to go towards, okay, they will go there. Okay, I can draw so many life lessons from this, but I'm not going to waste time by talking about it lah. Okay, kamu fikir sendirilah. Sebenarnya ini pun boleh dijadi satu pedoman harian ini untuk kamu semua. Okay, everyone needs a goal. Everyone needs to work towards something. Otherwise, you're just going to float around and do nothing. Okay, so we have to talk about this thing called the vacuum tube. Okay, so the place where thermionic emission happens is called the cathode. Okay, so in your module, in this one, please mark down here. Okay, thermionic emission happens here. Okay, seperti yang dijelaskan oleh our FR doppelganger just now. Okay, so thermionic emission always happens in the cathode, and which is usually a filament lah. Okay, why a filament? Filament, if you remember your menthol, yang warna kuning itu bukan. So the filament is usually this is really just a metal. Okay, it's just a metal surface. Then bila dipanaskan kan, you're going to get all these electrons yang dibebaskan, all the electrons that will be emitted. Okay, by thermionic emission. Okay, but in a menthol, in a light bulb, the electrons really can't go anywhere because you know they are being blocked by this lah. But in a vacuum tube. Okay, in a vacuum tube, since there is an anode over here, okay, the electrons that are formed that are released in the thermionic emission, okay, it will flow towards the anode. So a vacuum tube is a tube that consists of a tungsten filament, okay, which is a tungsten filament which is the cathode. Okay, this is the cathode over here, and an anode. Okay, and the filament is connected to a 6-volt power supply. Generally, yes, 6-volt power supply. Now state the correct terminal connection for the anode and the cathode. So the cathode is connected to the negative terminal of the vacuum tube. Okay, black here. And the anode is connected to the positive terminal of a high voltage DC power supply. Okay, so okay, so if you notice now, okay, this is the cathode, right? Okay, this is the cathode part, is connected to the negative terminal, okay, of this EHT. EHT is a high voltage DC power supply. Okay, now the anode part is connected, okay, connected to the positive terminal. Okay, and makes sense lah kan? Cathode is negative, anode is positive. Okay, but the question is why? Okay, why is there a high voltage power supply? Okay, kenapa kita mesti ada high voltage power supply? Okay, and then why is it called EHT? Kan? Why is it called high voltage? Kenapa kita panggilnya sebagai EHT? Now EHT stands for extra high tension. Okay. Please don't ask me why they call it tension. Why can't it be EHV, extra high voltage? I don't know. Okay, but they call it tension, so we're just going to use tension. So EHT is a high voltage DC power supply. DC is direct current. High voltage, we're talking about minimum 3000 volts. Okay, usually it's about 3000 to 5000 volts. So it's a lot. It's a lot of voltage. Okay, compared to the one that produced the thermionic emission, is just 6 volts only, very kesian. Okay, so the 6 volts is only to produce the electrons. Okay, but the extra high tension, the 3000 to 5000 volts voltage DC power supply, it has a very important purpose. We will talk about it in a little while. Okay, now what happens to the milli emitter pointer if you click the 6-volt power supply's S1? Where is the S1? I don't know. Okay, there will be no deflection. When you turn this on, oh, this is S1, sorry. So when you turn this on, there will be no deflection over here, okay, for a reason nanti saya akan cakap. But when you turn this on and this is still off, there will be thermionic emission happening over here. Okay, if you can see this picture over here, it has already glowing. It's glowing and it's showing you the glowing. So there is electrons that are being released. Okay, at this point, but the electrons are still stuck over here at the cathode. Okay, they haven't gone towards the anode yet. Now, what does this indicate? This indicates that there is no current flow. If you just turn this on, but this one is turned off, you're just going to get thermionic emission. Okay, you're just going to menghasilkan electron and then that's it. Okay, the electrons got no purpose in life. Okay, but when you switch on S1 and S2, now you switch on the extra high tension. Take a look at the jarum over here. It has turned to this side. You will find that there is a milliammeter reading. The pointer will deflect. And this indicates that there is a current flow. Okay, and why is there a current flow? Okay, so this is the explanation. So when switch S1 is closed, okay, when S1 is closed, current flows and heats up the filament. Okay, and electrons are emitted. So they're just not dibebaskan sahaja. Okay, but when we turn on S2, the high potential difference between the cathode and the anode. So there is, all the way over here is this extra high tension. Okay, which I said just now is between 3 to 5 kilovolts. Okay, so the high potential difference will accelerate the anode. And when it accelerates the anode, okay, it's going to menghentam the anode. And when it hentams the anode, the circuit is complete and current will flow. Okay, so current will flow and then come back here and then accelerate some more and then come back. And so on. Okay, so very important thing that we need to understand is this. When we provide the cathode, when we provide the cathode with a little bit of voltage, okay, the only thing that happens is thermionic emission. Okay, thermionic emission, and then all the electrons are just dibebaskan. Tetapi they don't have enough energy to move very fast because they already spend so much energy, dibebaskan daripada the cathode. Okay, so when they come here, they're like, oh, we're very tired. Okay, I don't want to move anymore. But then suddenly you provide the extra high tension over here. And suddenly the electrons are going to get a burst of energy and they're going to accelerate. So the function of the EHT is to accelerate the electron. The function of this voltage is to give enough energy for thermionic emission to happen. Okay, remember, if there's no voltage, kalau tiada S1 ini, tiada elektron akan terbebas. All the electrons will just stay where they are, tidak payah bergerak. But when you provided 6 volts, you're going to release some electrons. Okay, and when you give some more energy to the electrons yang sudah kena bebas, it's going to accelerate. And when it accelerates, it will hit the anode and there will be current flow over there. Okay, and that's the basis behind the cathode ray. Okay, what will happen to the milliammeter pointer, okay, when the connection is reversed? When we reverse the connection, okay, we find that the pointer does not deflect. Okay, if we put the anode here and the cathode here, okay, it totally doesn't make sense because anode is positive plate. Sini menjadi positive plate, sini menjadi negative plate. When the electrons are bebas, bila elektron dibebaskan, dia akan tertarik sudah kepada plate positif bahkan. So for what dia mau pergi cathode? Tiada, no point. Okay, because the electrons, they will not be attracted to cathode which is negatively charged. So there is no current flow. Okay, so we have to be very sure that when we release the electrons, dia dibebaskan ke cathode. Okay, because electrons are negative and cathode is negative. Okay, so kita letak itu elektron di sana dan kita pecutkan, we accelerate it towards the anode because the anode is positive. Just now you mentioned that, if we just put it normally, naturally okay, can't remember who said it just now. Just now you said, okay, if we put the anode here bahkan, okay, the electrons will flow towards the anode, okay, because they are negatively charged. Okay, very logical. Okay, but of course, what if the tube is very long? Okay, like in most cases, the tube is always very long. So if it's very long, we need to accelerate it. Okay, because if we don't accelerate it, it's not going to be able to get to the anode. Okay, so this is the explanation for this. Okay, so thermionic emission, okay, in summary, summary for just this activity lah. Okay, thermionic emission occurs when electrons have enough energy to escape from the surface of a heated cathode. Itu saja. Okay, so sini saja yang thermionic emission happens. Okay, Now, cathode rays is a high-speed electron beam. Okay, sekejap ah. Over here is where the accelerating happens. Okay, so we accelerate the electrons so that it will be at a high speed. And we call that high-speed beam satu sinar lintasan lah. Yeah, satu sinar yang, cathode ray lah. Cathode ray is sinar cathode. Okay, which is basically an electron at high speed. Okay, satu elektron dengan kelajuan yang sangat tinggi, okay, and it forms a beam lah. Okay, when it forms a beam, what is a beam? What is a beam in Malay? Beam lah, okay, beam lah. Okay, it's a high-speed electron beam because of the acceleration that we give it. Okay, so when a cathode is connected to an anode, okay, by a high-tension power supply, EHT power supply, a beam of electrons is accelerated to the anode. In reality, actually it's satu-satu elektron lah. Tetapi disebabkan ada banyak elektron yang terlibat, so what we will see is a line, a beam. What is a beam in Malay? Satu alur cahaya lah. Okay, to us it looks like alur cahaya because our eyes can only see that much. But in reality, when you go down at the molecular level, it literally is this, It literally is 1 electrons that are all flowing together, okay, towards the anode. Okay, pada tahap at the molecular level, that is what you'll see. But at our eye level, because of our sad human eyes, we can only see that lah. Okay, it's just going to look to us as one line. Okay, and the reason why there is that one line is because the electrons are being accelerated. Why are they being accelerated? Because of the EHT power supply. Okay, if there is no EHT power supply, this beam that we see, it would be very, very weak. Mungkin adalah, okay, dia akan tertarik juga, tetapi sangat lemah. Okay, because you're not giving it any motivation to to continue. Okay, so thermionic emission and the production of cathode rays, in a vacuum tube. This is the picture that I think this is in your textbook lah. Okay, wow, we haven't even finished explaining cathode rays. So now we have to talk about this thing called the electron gun. Okay, which actually we have in our lab, but it is, well, we can go back to the school. Okay, so what is an electron gun? An electron gun is a vacuum tube that produces a cathode ray. Okay, so the whole thing, okay, the vacuum tube, the cathode, the anode, that whole thing is called an electron gun. Dalam bahasa Melayu is literally senapang electron. Okay, so why is the space in an electron gun? This whole thing, this whole yang bentuk macam mentol ini bahkan, this whole thing is an electron gun. It doesn't look like a gun, I know, okay, but the whole space is vacuum so that there is no collision between the electrons and the air molecules. Because if there's going to be air molecules inside here, okay, memang susah dia akan menjadi pecut. Dia akan pecut dengan susah lah. Okay, it will always crash into the air molecules. We don't want that. Because if we crash into the air molecules, you're not going to get a very nice electron beam. Okay, so the working principle of an electron gun. So the electron gun consists of these elements. Okay, and I think this picture is in this one, right? So the purpose of the 6 volt, okay, is to heat up the filament. Okay, is to heat up the filament. Okay, so the purpose of 6 volt is to heat up the filament, and can you please write down there, okay, when you heat up the filament, okay, then you're talking about thermionic emission, which I still can't remember what it is in Malay, occurs here. Okay, in the filament. Okay, sini, thermionic emission occurs here. Okay, so the purpose of the 6 volt power supply is to heat up this filament only. Okay, and then the filament and the cathode will emit the electrons after being heated lah, okay, by the thermionic emission. Okay, and then the anode, the purpose of the anode here is so that the electrons that are in the cathode will accelerate towards the anode. Okay, and then the extra high tension here is to provide the high potential difference between cathode and anode to accelerate the electrons to anode. Okay, to accelerate that's the purpose of this cathode. The extra high tension lah, untuk membenarkan to let the electrons to be dipecahkan lah. Okay, dipecahkan. Now, the purpose of a pendant floor screen, so at the end of a usually, at the end of a senapan electron or of an electron gun, there is a screen that is coated with this material called pendant floor. Pendant floor yang sama macam kita punya lampu pendant floor itu. Okay, so but it is now a screen lah. So what is going to happen here is you're going to have all these electrons, they are going to come here and they're going to hit, dia akan menghentam this pendant floor screen. And when they hentam the pendant floor screen, they are going to convert the kinetic energy, to light energy. And that's why we can see the picture on the cathode ray oscilloscope. You know this one? Yang kita nampak tadi? Or even in the TV, yang lama-lama itu. Okay? And that is just one, that is just one ray, one beam of electrons. Imagine your TV, how many thousand, I'm not saying that there's 1,000 electron guns, but I'm just saying that, there's a lot of electrons that are flowing. Okay, there's a lot of electrons that are flowing at very high speed and hitting the screen so that you can see the picture of your favorite actor or actress on TV. Okay, so the pendant floor screen is very important. Okay, and our old monitors, our old TVs, really, they have this pendant floor screen. And then when you think about it, and I don't know how many of you have experience with this, okay, this is probably a boomer or Gen X experience, okay, but in the old TVs, when you turn it off suddenly, okay, when you switch off the TV, you will feel some sort of static. You will feel some sort of macam ada static lah, okay, I don't know how to say it in Malay. Static lah, you will feel like a little bit of static, okay, because there are still electrons that are flowing, and what you're feeling over there is the electrons on the TV screen. Okay, they are hitting the screen of the TV, they're hitting the pendant floor screen at very high speed in order to convert the kinetic energy to light energy. Okay, so again, not to say in conclusion, okay, but cathode rays can be used in a picture tube of a television, a cathode ray oscilloscope, and the visual display on a radar screen. You know, the radar screen where okay, incoming missile. Okay, all those are applications of cathode ray. But cathode rays, okay, the question is this, cathode rays usually produce only one ray of electrons. Okay, so how is it that on our screen we are able to see so many rays of electrons? Okay, that is a question for another day and another this one. But the idea behind the discovery of the TV, behind the cathode ray oscilloscope, behind the radar screen, okay, is the idea of thermionic emission to release electrons and you accelerate the electrons, so that when it hits the screen, it will convert the kinetic energy to the light energy. Okay, and as an introduction, okay, this is probably where we will stop today, because if you want, in tomorrow and Thursday's class, we will go more in depth into this. But for today, we need to understand how one ray is formed and how one dot only, okay, one dot on the screen is formed. It's literally one dot there. You see, one dot only. Okay, you know the term now, it means nothing to us but pixels. Okay, pixels. If you're very techie savvy, well, not like me, I'm not techie savvy, but I kind of understand what this is. So you know the computer screen, right? Okay, actually there are many grids. Okay, there are many grids, and then every grid is, I think so. Okay, if anybody is watching this and you are saying, oh no, sir, salah sudah, please correct me. But I think that every single square, okay, is what we call a pixel. Okay, and in the old days, during the old TVs, right, every single electron beam is one pixel. So you're talking about, let's say it's like, fine, camera, okay, 22 megapixels. Mega is 22 times 10 to the power 6, 22 million pixels. Okay, so you're going to have at least 22 million electron beams that are coming towards you at the screen. Okay, this is I'm oversimplifying this. Okay, it's a very, very, very more complicated explanation than this. But what I want you to understand is this. When thermionic emission happens, okay, and when we pecutkan the electron, you're only going to get one dot, which is one pixel. Okay, it's just literally just one dot. Okay, so how does this one dot, when we gabungkan, then we bentuk muka di atas TV. When we see the picture on the TV, how do all these dots come together? Okay, does it mean that in the TV last time there are 1,000 over electron guns? No, it's not that. There is a further technology to that. But the idea behind the TV, the idea behind the cathode ray oscilloscope, okay, the idea behind the radar screen. Have you ever wondered why the cathode ray oscilloscope and the radar screen, do you know what color is the display? Have you ever wondered what is the color of the display? Do you remember?
Green.
Yeah, green. Okay, have you ever wondered why is green color? Who in the world chose green color? Why can't it be red? Why can't it be blue? Why can't it be yellow? Okay, why must it be green? Okay, there is a lot of explanation behind that, which I will not go into in this chapter. Okay, but suffice to say that there is a reason why it is green, and it has something to do with the fact that when you pecutkan, okay, bila kamu pecutkan the electron and it hits the pendor floor screen, okay, pendor floor screen, okay, it is going to produce a color effect, which is usually is green, okay, because so this is a little bit of chemistry, okay. So, but the idea is this: it's only one beam, okay. How did that one beam become thousands and thousands of beams on a TV, on a radar screen, on an oscilloscope? This is something that if you want to know, you have to study more electronic engineering when you go up to higher levels. Okay, so for today, what I would like all of you to do, there's no homework, but I would like you to review this lesson again. Okay, I want you to review this lesson. Make sure that when we go into class tomorrow, you know what is thermionic emission, you know what causes thermionic emission, okay, you know why we need to accelerate to the anode, okay, and how we accelerate it to the anode. And number 3, you know what is the function of the pendor floor screen. Okay, the pendor floor screen, why is it so important, the pendor floor screen in an electron gun? Okay, so there are a lot of new things today. Okay, just like everything in physics now, everything is new. Okay, but it is based on something that we have learned before. We have learned the concept of acceleration. We know what is anode and cathode. So you need to have all these basics in order to understand what is happening over here. Okay, so thermionic emission. Okay, why do we need to accelerate and how? Okay, and what is the purpose of the pendor floor screen? Go and review. Just make sure you know this so that when you enter class tomorrow, you don't get lost and like, oh no, I've forgotten what sir says yesterday. Okay?